Scott Sneddon, Nuage Networks. Not New Age, it's the French word for cloud. The reason for that is because we're a part of Alcatel-Lucent. Alcatel's this French company, and so we picked the really obvious choice for a cloud networking company and called it the French word for cloud. For better or for worse, it's working for us. We've had a product on the market for a year and a half now. We're just getting ready to ship 3.0, so we've got a fair amount of experience in this space. We have a product that is a network overlay solution. So primarily targeted at data center, but we bring in a lot of the intellectual property from the ALU 7750 router line in our control plane. So there's a nice way we interact with BGP and MPLS networks to sort of extend these data center overlays into an MPLS WAN fairly intelligently. But that's not what I'm here to talk to you about. I'm here to talk about a bit of a higher layer that's part of our product, but I'm going to talk about it in the context of some open source activities and what's happening in OpenStack and a little bit in Open Daylight around policy abstraction and what Russ was talking about earlier about kind of rethinking how we do these things. You guys know all this and you've heard it several times. There's been a lot of innovation. I will argue, and I was talking to Brian Field earlier about this too, I will argue, Russ, that there is room for innovation in white box, and that's through software and small startups that don't have to invest in chip development. So, but why did we do this and why did we start looking at this? It was really to reduce cost, to reduce complexity, to give a self-service model to my cloud consumer or the people that were actually using my network, give them a way to start provisioning their own services. You know, can we make it cheaper? Maybe. Can we make it more efficient? I think so. The reason for this and why it's important is that there's been a huge change in consumption. There's a very large shift in how people are using services and resources on the network today. And I don't mean the network itself, I mean the things that are on the network, and that's primarily cloud. I've moved to this model of instant gratification where I can go to AWS or to a cloud portal or to some compute service and turn on an application in seconds. I can select from a catalog of services and kind of construct my application on the fly and have these things up and running in no time at all. So the consumer expectation is shifting and the consumer is kind of demanding a little bit more. We've seen a lot of innovation around server virtualization to enable that. It is server virtualization that sort of created this whole cloud market. Yes, it is a mainframe, but it's a mainframe with self-service and not necessarily a NOC that provisions these things for us. The network hasn't necessarily kept pace with that. We still go through help desk and change control and trouble tickets and manual processes to provision these services. So there's a bit of a disconnect. Interesting paper by James Hamilton in 2010, who was a architect at Amazon Web Services, about how the network is in the way and how by optimizing some of these processes, we can make the compute system more efficient. We've seen innovation in SDN where things are getting better. We've automated some things. We've introduced vSwitches and controllers and some interfaces through OpenStack and Neutron and things where I can start to automate some things, but I'm still not automating end-to-end. I'm still going through a security audit department to define the ACLs that go into that automated process. And so, you know, I fixed some of these things, but I haven't really tackled the whole problem. So we're accelerating things, we're making marginal improvements, we're making great improvements in some areas, and it is a really interesting thing to solve, but we're still not solving the problem. We still have this problem of committees, of bureaucracy that define the network service. We have this problem of reviews and audits and all of those sorts of things that go into defining and creating a network service. And in the model of Amazon Web Services or OpenStack or these sorts of things, I've actually taken some of the responsibility for that manual process and definition and control and shoved it onto my DevOps team. So yeah, it's great that I gave my DevOps guys all these tools to go self-provision, but now I'm forcing my DevOps teams to understand ACLs and ports and routes and things like that. They're really, really smart application people. They know how to solve hard problems around storage and servers and all of those sorts of things. They're not necessarily network engineers. And so is that really what I want to burden my DevOps team with, is networking details? As an example, OpenStack Neutron is the open source project around the OpenStack cloud platform that's defining network services and network APIs. All of us in the vendor space are developing products around this and plugins to interface with these APIs, so all of us in the vendor space are of course participating in these open source projects. But so Neutron lets me create these logical building blocks to create network topologies. I have a neat new CLI that runs on my Linux box that lets me go provision a network, provision a subnet, define a router, define ports, and then connect virtual machines to those ports. A lot of networking detail there that maybe my DevOps team didn't really know before. It's not really abstracted, it's not really consumable. So the DevOps guys actually have a different view of things, and they actually understand things a little bit differently. The DevOps team understands how they want to group their applications together. They know their web servers have to probably be on some common zone or area. They don't care if it's a subnet or anything like that. They just know that they have to be connected together. And then they have to talk to their app servers, and the app servers have to talk to the database servers. And maybe I need some security rule in between there. And the app teams understand the ports that need to be open and things like that, but shouldn't necessarily have to care about how I open those ports and how I define an ACL. And am I using a Cisco ACL or a Juniper ACL or something else? And so with all of this, though, I still need a way to manage the network topology itself. And so the network administrator still wants that view of a service chain and the paths that these packets take to make those connections happen, and where I physically apply those ACLs and firewall rules and so on. So what we need to do is kind of change how we look at these things. And so we at Nuage and others in the industry are starting to look at this policy approach to networking, which is really just templates. It's network templates that we define with the DevOps team, right? So a network engineer and a security administrator could sit down with the app team, define the network service for that application, go through all of that manual process that we need to do to define routes and subnets and connections and paths and ACLs, but we do it once, and then we save it as a template into some sort of policy system that matches the user of that compute resource to some identity in the network policy engine, and then automatically deploys those templates in a rinse and repeat fashion over and over and over again. So I go through that manual process once. I can audit and track the usage of all those templates as they're deployed, so I have a real-time way to audit the usage and compliance of network security for all these things. But the DevOps team can just consume these templates when they need them on demand. So there's activity in OpenStack, and I'll post these, I think the slides will be online here, and I'll post them on SlideShare if not. Where we're working on a kind of standard way of defining these network policies and these network templates. And our friends at Cisco and our friends at IBM and several others are working very hard on this, contributing to this code. What this does is this just gives us some new definitions. We have a definition for an endpoint, which is anything with an IP address, most likely a server or a virtual machine. We have groups of endpoints, which is self-explanatory. And then we have a contract, which is a group of policy rules. And those policy rules are ACLs. They're firewall rules, they're security rules. Those are contained into a contract. And then those are presented to a user to just consume on demand. So this gets us to this model here where, very similar to the application development environment, where I would define source code, I would compile that code to be ready to run on a server, and then when I actually need to run that application, that code is deployed onto the compute. In a networking model, we would define a policy, which sort of becomes our source code. That policy can then be translated into the specific deployment requirements if I'm using Cisco's network or a Nuage overlay or a VMware solution. And that translation happens through some plugin to an open source project like OpenStack Neutron. And then those attributes are deployed onto the network at service instantiation time when the application started in an automated rinse and repeat way. And I'm not manually touching the network each time I do this. I'm doing it more like I was doing in the application space, where I'm just running the application or deploying the topology automatically. So why do vendors like Nuage and Cisco and VMware participate in these open source projects? Well, there's a few ways, or a few reasons. Well, the simplest answer is because we want to sell you something, and because we want these open source tools that you're using to sort of match the products that we've built. But We also see that things like OpenStack are sort of becoming a new standards body. And while the IETF is doing great things around network protocols, whoa, time's up. The OpenStack Neutron project, for instance, is doing a lot of things around defining standard APIs and standard network policy definitions that I think we can all leverage and we can all build products around. So Nuage has a product that delivers a lot of these policy abstractions today. So does Cisco, so does VMware. We are working hard with OpenStack to make those policies easily consumable in the open source compute platform you'll use. And that's kind of the end of my story on how we get these things all magically automated. And I'll be around all day to talk about this a little more, argue over the validity of overlay networks versus underlay, and thanks for your time.